So thanks for coming to the San Francisco Bitcoin Meetup. Our first talk tonight is Greg Slepak from okTurtles Foundation, and he's talking about securing communications with blockchains.
Thank you, Paige. All right, so thanks everyone for coming. I'm going to be talking about securing communications with blockchains. So to start, I'd like to point out that the internet has a problem. In fact, the internet has many problems. But the problem that I'm going to be talking about today, and the problem that we're trying to solve, is the problem of authentication. Authentication is the problem of Mr. Miyagi. Is that really you? Not Mr. Miyagi. The way that it works online today is actually a little bit more deceptive. They tell you that, yes, I'm Mr. Miyagi, but the reality is that they're not Mr. Miyagi. So let's give an example of how this works with HTTPS. When you connect to a server, your browser is sent something that's called a certificate, also referred to as an SSL or TLS certificate. And your browser checks to see if that certificate is legitimate. It is, after all, what is supposed to confirm the identity of the website that you're trying to connect to. How does your browser do this? When they invented SSL about 2 decades ago, they decided to outsource this responsibility to third parties called certificate authorities. And today, every browser ships with several hundred certificate authorities that it implicitly trusts on your behalf to make these decisions. In total, there are over 1,000 certificate authorities out there that operating systems and web browsers trust. So, it's not that it trusts all of them. It's not like a unanimous vote. It's just one vote is enough. So, a single person needs to say, yeah, this certificate is legitimate, and your browser will then believe it, and will tell you that the connection to this website is secure. We had a problem a couple of years ago where such an attack happened on DigiNotar, and I believe several hundred websites had certificates issued for them fraudulently. The CEO of Komodo had this to say, that it seems that they, the attackers, need these certificates. And they will not stop attacking. And the reason is simply because they can't. The system is fundamentally broken, and it invites hackers and governments and disgruntled employees and whoever wants the amazing power of being able to impersonate any website on the internet that they choose. So I'm here to tell you that there is this thing. Some of you might have heard of it. It's called a blockchain. And the blockchain can secure online communication end-to-end. You have no idea how difficult it was to find an appropriate picture. I'm searching butts touching. Forgery.
I bet there's a lot of inappropriate ones there.
Without relying on central authority figures. Or the untrustworthy. Something about Namecoin and DNSChain, insert technical details here. Yay, the end, thank you. So, how do we solve authentication? Authentication is really a key distribution problem. What does that mean? You can think of this simply as an identity distribution problem. So, to get a little bit technical, I will introduce a word that users should never have to hear, and that is a public key. In cryptography, a public key represents your identity. And you can think of it as your face. Anyone can see it, and more importantly, anyone can copy it. It doesn't matter. That, by the way, is not Barack Obama's face. That is a 3D model of Barack Obama's face. Your private key, you can think of it as your soul. It's what prevents others from impersonating you. So, to go back to Alice and Bob, who want to communicate with each other. The way that this traditionally works, and Alice can be, for example, a user who wants to connect to Facebook, and Bob can be Facebook. Or Alice can be Alice, and Bob can be Bob Marley. So both of them have public keys, and in an ideal world, they simply exchange these public keys. Alice gives hers to Bob, and Bob gives his to Alice. So how is this done today? Let's go over HTTPS to start. In HTTPS, the system that does this key exchange is called X509. And in X509, these third parties are able to magically sign certificates on behalf of websites and then give them to those who want to connect to those sites. The problem is that these keys don't really belong to the owners. The owners don't have control. They delegate that control. They outsource that control to third parties. So that's why we have the man-in-the-middle problem with HTTPS. So Google runs into this problem constantly. Google is a frequent target of these man-in-the-middle attacks. And it is a problem for them because it harms their reputation when their users in various countries are being man-in-the-middle by those governments. So Google has an incentive to solve this problem, and the current solution that they're working on is called certificate transparency. We reviewed certificate transparency, and you can go on our blog to read about it. It's a very complicated system that doesn't change X509. It just puts some bandages on top of it, and those don't really help. In certificate transparency, they will talk about various different kinds of proofs, but these proofs do not detect misissued certificates by rogue certificate authorities, even if gossip of so-called sign treat heads successfully occurs. See our blog post for technical details. In the best case scenario, should everything go according to plan, the best that you can hope for with certificate transparency is that misissuance is detected after an attack has occurred, the damage has been done, and you are able to figure out what certificate authority is responsible. And then what do? You go to the certificate authority, complain, and what do they say? They simply throw the blame on to hackers, most likely, that they were hacked. What else are they going to say? So what about chats? I'm going to pick on Apple for a little bit. And the reason I'm going to pick on Apple, even though they're a company I really admire, is because they have a little bit of not so truthful copy on their website. If you go to the Apple privacy page on iMessages, you'll see that this little paragraph here. And in it, if we zoom in closer, you'll see that Apple says that Apple has no way to decrypt iMessage and FaceTime data when it's in transit between devices. Furthermore, they say we wouldn't be able to comply with a wiretap order even if we wanted to. The problem with that is that that's not true. The way that iMessages works, according to their own iOS security paper, and confirmed by various third parties, is that your device generates public keys, it sends them to Apple servers, and then when you want to talk with somebody else, Apple is responsible for sending the correct public key to the person you want to talk with. The problem here is that there's absolutely nothing stopping Apple from creating fraudulent keys, sending them to the people who are communicating, and then transparently decrypting and re-encrypting those messages as they go. So,
But if they don't, do they hold a private key? Or
no, they don't hold the private key. No,
So
no.
how can they decrypt without the private key?
Because they send their public key.
Oh,
that
they
create.
send their public key.
That's
Got
right.
it. Got it. I see what's going on.
Yeah. So let's look at how this would work, how we solve these problems with a blockchain-based approach. We're working on a project called DNSChain. And in effect, you can think of it as one pin to rule them all. We use a technique called certificate pinning. What does that mean? This is a common technique. It's standard. It basically means that Alice because she either runs her own DNSChain server or one of her close friends runs it, she knows a priori the fingerprint for the public key of that DNSChain server. And knowing that knowledge in advance allows her to establish a man-in-the-middle proof connection with the DNSChain. Nobody, except with like quantum attacks or a bug like Heartbleed, nobody can intercept the communication on this connection. She will reject any other certificate sent her way. And with that one man-in-the-middle group connection, she is able to create man-in-the-middle group connections to all of the other websites on the internet. She puts her public key into Namecoin, and here's how it works with Alice and Bob. Alice puts her public key via DNSChain into the Namecoin blockchain, and that propagates out to the rest of the Namecoin network. And she, in a sense, is registering her identity. She says, I want to register ID/Alice, and here's my public key for that. That gets sent out to the rest of the network, and it appears in Bob's blockchain, which he has locally stored on his server. So you can think of it as a decentralized, distributed, secure database. And all of this is protected by proof of work. You guys can ask me about 51% attacks after. The short of that is that it mostly amounts to censorship. It's not actually that big of a deal for these purposes. So alternatively, both Alice and Bob could be using the same DNSChain server, which also has locally running on it Namecoin. That's if they trust whoever is running the server. And they can exchange keys that way. The blockchain allows for user-friendly applications. Applications that people are familiar with today for insecure communication. The blockchain makes it possible to have secure communication with a level of ease of use that reminds people of today's insecure communication. So how does email work? Email works just like normal for domains that are stored in the blockchain. The way that that works is that whoever owns the domain, for example, gmail.bit or gmail.com, if Google migrates the .com into the blockchain, there's a way to do that. Alice's email client, when she types in bob@gmail.bit, gets the public key for gmail.bit over a man-in-the-middle proof connection, so there's no problem there. Then uses that public key to request Bob's public key from gmail.bit itself. And that's also done over a man-in-the-middle proof connection because it's protected by the first one. And so this allows you to always have the right key in a sense. There's no revocation problems. You just have whatever is the most recent entry in the blockchain is the most accurate one, and that's the one that you use to encrypt email. So from an end user perspective, this works just like regular email, basically. You just type in the person you want to talk to, and you hit go, and that's it. There's that initial step of registering it, but beyond that, clients can automate all that stuff to a level of ease of use that matches today's unencrypted communications. How does it work for chats? Well, let's use the example of iMessages. Chats work just like iMessages does today, except instead of trusting Apple, you trust yourself or a friend, or if you want, and if you trust Apple, you can trust Apple. They have their own DNSChain server. The pros of this system are that it gives you real ownership, it provides censorship resistance, and it's secure. The cons of this system are that it provides real ownership. With real ownership, you have the downside of real loss. So for example, today when you register a domain, or say, for example, somebody else registers a domain that you have a trademark over, you can go to ICANN and complain and sue them and have it transferred back to you. You can't do that with the blockchain. If somebody actually has a domain, you can't take it back from them, and so that's a double-edged sword. You have to that can be dealt with only if you know through the legal system who actually owns that entry. If you don't know, you're kind of out of luck. Maybe wait until it expires and then try to grab it if they don't re-register it. But it makes sense for a whole lot of applications today. It makes sense for marginalized communities who have their domains taken away from them en masse. It also makes sense for messaging applications like iMessage and for email. And there's no reason that the two systems can't exist alongside each other. Some suggestions for solving issues with the way that Namecoin currently works is, for example, say if you lose your private key, that could be an issue in today's system. So we recommend creating password-based keys the way that Minilock does. Minilock is a new endeavor made by the creator of CryptoCat, Nadim, I forget his last name, starts with K, I believe. And he basically forces users to come up with really strong, really long passwords. And based off of those passwords, he generates a public-private key pair. So that password-based key can be used to create a super master key that overrides others in case those others get lost. Another recommendation is provider-based identities, such as the example I gave already with bob@gmail.bit. And to wrap up, I'd like to mention some awesome people who are working in this area. The folks at OpenBazaar are integrating DNSChain for authenticating identities on the OpenBazaar network. OpenBazaar, if you haven't heard of it, is a fantastic project. It's a decentralized marketplace. So you can think of it as a decentralized eBay, effectively. Of course, the Namecoin developers who have been working hard and long on the Namecoin blockchain deserve a lot of praise and a lot of money also to help them with their work, because they're doing good stuff. And the folks at OneName who are currently subsidizing Namecoin registrations so that you don't have to pay anything to get your identity stored in the Namecoin blockchain. They're doing a lot of good work too. And finally, thank you all for coming here and listening to this talk. If there's any time, I can take questions.
I had a question, yeah.
Sorry. Yeah,
Okay. Does OneName allow you to register a name with the regular ID namespace, or do they have their own namespace?
They have their own namespace.
Right. So they don't really let you register a .bit domain or anything like that, right?
They're focusing on identities. So the big issue that we have today is that nobody owns their identity these days online. People's identities, the closest they come to is their Twitter profile or their blog, and you don't own your Twitter profile, you borrow it from Twitter. You don't own your blog, you rent it from ICANN. So with the blockchain, you actually own your online identity, and they're focusing on, their namespace is called u/. It's just their thing. I think it follows a very similar schema to ID/, and I think they're considering merging the two as well. I encourage them to do so. I think it's a good idea. Show good faith to the Namecoin developers as well. So, yeah.
Any other questions?
So what's the actual state of being able to, like a normal user being able to go to a .bit domain right now?
I believe there are Namecoin registrars out there. The problem with them is that you have to trust them. You know, they essentially generate the private keys, and so you don't completely own your domain. The real current state of registering domains in the Namecoin blockchain is absolutely terrible. And it's a great, huge opportunity for somebody to make a domain registrar that allows people to securely register their own domains while holding on to their private key and not sharing it. I believe the OneName folks are working on that. And they have certainly demonstrated competence as far as allowing people to register their name, their identities in the Namecoin blockchain. So doing domains is not too much more difficult.
Yeah, I mean, in terms of actual end users being able to navigate to like a .bit domain in a normal browser, like what is the state of that currently?
Right, so if you point your DNS server to ours, we're running our own DNSChain server that we just made public. If you change your DNS settings, you'll be able to access .bit domains. The next step is accessing those domains securely. Overriding the browser's verification mechanism, making it not rely on X509, but on DNSChain, so that it can verify the fingerprint via the blockchain. We're working on that. Browser extensions are really difficult to implement. But that's something we're working on currently.
Last question, anyone more?
Yeah, if the domain name system is built on top of Bitcoin, can you also do things like multi-signature, so you can have a name registered with multiple keys?
Yes, I believe so. Pretty sure.
Not currently.
It's Namecoin.
Yeah, Namecoin doesn't have multi-sig right
Yeah.
now.
Well, I'm not sure if Namecoin has multi-sig implemented at the moment, but there's nothing preventing them
Namecoin
from
does
doing
not
that.
have multi-sig at the moment.
Okay, cool.
That will be fixed as soon as the code base is.
Are you Ryan? Oh. So Ryan's one of the core Namecoin developers. He knows what he's talking about. How are you doing? I don't think you're doing okay. Are we done with questions, or are we moving on to the next one?
We can still take questions just because we're in
Have you had a chance to check out the EFF announcement today with Mozilla and
Yes.
San Francisco? Do you have any thoughts on that?
Yes. I forgot the exact name of the endeavor that they're working on, if you remember. Let's Encrypt. Yeah, okay. So what that is it's essentially two things. It's an announcement of the second free certificate authority. So in other words, you don't have to pay, with this certificate authority, you don't have to pay to get a certificate that doesn't do anything. So that's, an improvement.
Still a centralized authority.
Well, it's not just centralized, but it's also undermined by all the other authorities out there who are not trustworthy. Just because you get a free certificate from them, the system is still broken. It's not going to protect your customers. You could pay $0, you could pay $300 for your certificate. It still doesn't protect your visitors from man-in-the-middle attacks. It's a good thing that they're doing that, because it allows people to kind of go above HTTP and not have to pay for certificates that don't work. We don't, that's not a good thing. So that's an improvement. The second thing that they're doing, oh, by the way, I should mention the first certificate authority that is currently accepted by all major web browsers that does that is called Start SSL, and they've been doing that for a while. So the second thing that the announcement was about was a utility for server administrators to create these certificates and set up their websites with them, and make it really easy to do that. That's another big pain point right now, and why so many websites haven't moved to HTTPS, because of how difficult just creating a certificate is with the open SSL command. So that's the second thing that they announced.
More questions? Last one?
All right.
Thank you, Greg.
No problem. Thank you, Ken.